So in this video we're going to be looking at horizontal translations of the toolbox functions that we talked about in video 1. The basic idea is that if we have a real number h that's greater than 0, or a non-negative real number h, and a graph f of x that is the graph of one of the toolbox functions that we saw in video 1, then if we make a new function g of x that's equal to f of x plus h, that if we want to graph g of x, we just take the graph of f of x and shift it h units to the left if h is being added to x. Similarly, if we create a new function g from the function f by subtracting a positive number h from the input variable x, then the graph of g is just the graph of f shifted 8 units to the right. So we're going to go ahead and look at an example. I'm going to give you the PowerPoint slide in an email, but I'm going to work the example out in GeoGebra. So here I've got GeoGebra open. So the directions were to construct a graph. See, I want a pen here with a thicker lead. So we wanted to construct a graph, a new function, g, that we build from the function f by adding 2 to the input variable. So the first step, I think, in these is to look at the function that you're given. And so here I have a function, and identify which toolbox function it is. So this particular guy, he's the toolbox function f of x equals the square root of x. And that's why the introductory video just looked at the shape of each of the toolbox functions. And so what we're really trying to do is construct a new function g that is given by taking the toolbox function, the square root of x, and replacing the x with x plus 2. And the idea is that if we're adding 2 to the input variable x, the graph of g should just be the graph of f of x, which I've already drawn here in GeoGebra. It should be the graph of f of x shifted 2 units over to the left. So step 1 in graphing g by using the toolbox function f is to take your toolbox function, draw it. I already have it on the screen. You typically won't, but you'll be told what the toolbox function is. And then once you draw it, draw in those key points that we drew in video 1. Give yourself about 3 key points. So we get the origin, we get the point 1, 1 as a lattice point, and the next nice lattice point is the point 4, 2. And then the graph of g should just be the graph of f of x equals the square root of x, shifted 2 units, and because we're adding, it's going to be 2 units to the left. So the origin is going to shift over 2 units to the point -2, 0. This point 1, 1 is going to shift over 2 units to the point -1, 1. So notice that the outputs aren't being affected. The outputs are still 1, outputs are still zeros. This is at 4, x equal to 4. It'll be shifted 2 units horizontally to the left over to the point 2, 2. The output's not impacted. So horizontal shift because the input variables, the x's, are graphed on the horizontal axis, and this 2 is being added to the input variable, so it impacts the horizontal positioning of the graph. Your check on work, if you add each of these in, -2, if you plug it in -2 plus 2, it should give you the 0 back. -1 plus 2 gives you the 1 back. The 2, if you plug it in here, plus 2 gives you the 4 back. And then what you do, once you get those 3 nice points shifted to the left, you would freehand draw your graph through them. I'm horrible at freehand drawing, so I have on purpose put things into GeoGebra so that I can kind of cheat here and freehand draw with GeoGebra the graph through those points. I don't want to lose the lattice points, though the lattice points are important. I'm trying a new tool today, so I'm feeling inept. So the thing that students have a difficulty with that I've noticed is they see the plus and they ask the question, why doesn't the plus shift the graph to the right? Why doesn't it shift it in the positive direction? But what you need to think about is what's going on when you add 2 to the input variable. This plus 2 is making the inputs bigger. You're adding 2. So what you expect is to get to the outputs faster. You expect to get to outputs faster because the inputs are made bigger by adding 2 to x. So the graph has to shift to the left so that if you're a person walking from left to right on the number line, notice if I shift the graph to the left, by making the inputs bigger by adding the 2, I get to the graph faster, right? I get to the graph faster. If I'm subtracting the inputs, it takes me longer to get to the same output because I'm subtracting from the inputs, and then I get to the graph less quickly. The graph has to move to the left. So there's the first example. The second example on that slide, see if I can get my eraser here and get some of the stuff out of my hair for a minute. The second example on that slide said build a new function h of x, or graph a new function h of x that's built by subtracting 3 from the input variable. So this means it should take me longer to get to the picture because I'm taking 3 away from each input. And so this is the function h of x equals square root of x is the toolbox function. Everywhere I see an x in the toolbox function, I'm replacing it with x minus 3. So I need to graph h of x, and all I need to do is take these nice lattice points on the toolbox function and shift them 3 units to the right. So 4, 2 is going to shift over. I'm adding 4 to 3, I'm adding 3 to 4 because I'm shifting 3 units to the right. So I go start here, 1, 2, 3. That's going to wind up at the point 7, 2. The point 1, 1 shifts over 1, 2, 3. I'm adding 3 to this 1 to get a 4. I get the point 4, 1 on the graph, and I add 3 to the 0, shifts it over 1, 2, 3. So now the graph starts at 3, 0. And again, I would, if I were doing this for homework, I would freehand draw. I'm not going to try to freehand draw with the computer pen, so I'm going to just turn the graph h of x equals the square root of x minus 3 on, and you'll see that it passes through those lattice points that I drew, and that's the idea here. So if you move forward one slide, I have one more example if you want to see it. So the downside to this piece of software that I'm trying that's letting me annotate is it doesn't let me rectangle select and erase, at least not that I found yet. So I have to erase, which just adds a bunch of extra time to the video, so I need to figure out how to fix that. So the next example said build a new function g of x that is built from f of x by subtracting 1 from the input variables. So subtracting 1, that's going to shift the graph 1 to the right because the outputs will happen, I'll have to put in larger numbers to get the same output. So it takes the entire graph and shifts it to the right. I want to recognize the parent function, or the toolbox function. So this is the squaring function from video 1. This is f of x equals x squared. And again, I want to grab a few nice lattice points on it. And that's the point -1, 1. This is the point 1, 1. This is the point 0, 0. And subtracting 1 from the input variable is going to slide the entire graph over 1 unit. So it slides this 1 over to 2. The output stays the same. The 0 slides over to the 1. The output stays the same. Whoop, and I grabbed the color I don't like. And the -1 will slide over 1 as well to the point 0, 1. And then I would hand draw through these 3 points a new parabola. And if I did that, the parabola that I hand draw should pick up those 3 lattice points that I drew in. So the other thing that we were asked to do, I'm going to move this guy out of my way a little bit. This was the point -1, 1. The other function we were asked to graph is the function h of x that's built from f by adding 2 to the input variable. So again, that means h of x is going to equal, this is the squaring function, and in the squaring function we just replace the x's with the x plus 2. And because I'm adding 2, I'll get to the outputs faster. That's going to shift my toolbox function to the left by 2 units. So I take each of the nice lattice points, I shift them 2 units to the left. So this shifts over to -3, 1. This point 1, 1 shifts over 1, 2. This point 1, 1 shifts over 1, 2 units to the point -1, 1. And this guy shifts over 1, 2 units to -2, 0. And then of course I would hand draw a nice parabola through those points. But for me it's easier just to turn that function on and show that it does pass through the lattice points.